In this video, we will be proving the cosine rule. So our cosine rule is a squared equals b squared plus c squared minus 2bc times cos a. And so what we're going to do first is we're going to label the angles on our triangle. So we'll call them A, B, and C. And these will all be in uppercase. Now we will label the sides opposite the angles A, B, and C, but they will all be in lowercase. And now we will draw a vertical line from B down to the base, and it will be perpendicular with the base, and we will call this line H. Now we will label the point where H meets the base AC as point D to aid our explanation, and we're going to label AD as X, so we'll take that length as X, and we'll take the length of DC as B minus X. Now we will take into consideration triangle ABD. So by using Pythagoras, we get c squared equals h squared plus x squared. We can rearrange this to give us h squared is equal to c squared minus x squared. In a similar way, we will take triangle BDC, and so by using Pythagoras, we get a squared is equal to h squared plus b minus x the whole squared. And we can rearrange this to isolate h squared, and we get h squared equals a squared minus b minus x the whole squared. And so our first equation we'll label equation 1, and our second we will label equation 2. So by equating 1 and 2, we get formula c squared minus x squared is equal to a squared minus b minus x the whole squared. And so we're going to expand b minus x the whole squared to get a squared minus, in brackets, b squared minus 2bx plus x squared. And this is equal to a squared minus b squared plus 2bx minus x squared. And so now we can bring back c squared minus x squared. Now we can simplify, and first we can remove the x squareds on both sides, and we're left with c squared is equal to a squared minus b squared plus 2bx. Now, if we go back to triangle ABD, we can find that cos of angle A is equal to x over c. Because this follows the SOHCAHTOA rule, so CAR, where cos of theta is equal to adjacent over hypotenuse. And so, by rearranging cos of A equals x over c, we can isolate x, and we get x is equal to c times cos A. And so if we label the equation c squared equals a squared minus b squared plus 2bx as equation 3, we can substitute our value for x. So we've calculated x as c times cos A. And if we substitute that value into equation 3, we get c squared is equal to a squared minus b squared plus 2bc cos A. And so if we move b minus b squared plus 2bc cos A to the left hand side of the equation, we can get b squared plus c squared minus 2bc cos A is equal to a squared. And if we just flip the equation over, we get a squared equals b squared plus c squared minus 2bc cos A. And this is our cosine rule, and we have proved it. As always, thank you for watching, and make sure you subscribe so that you don't miss out on any new content.